A near-field electromagnetic scanner is an effective tool for locating the sources of electromagnetic interference. The near-field plot of the magnetic field at a certain frequency reveals much more information compared to a traditional handheld sniffing with a probe and a spectrum analyzer. The near-field scan shows patterns that even an experienced EMC engineer cannot form inside his head. In this video, we will demonstrate Center for Industrial Electronics in-house near-field scanner. First, you place the PCB in the robot's workspace, then you can begin to set the scan parameters in the graphical user interface. To start, you just click on the Start Scan button and the scan wizard will guide you through the whole process. You give your project a name, then the program will detect the PCB's position. Next, the wizard asks you to set the desired height of the scan and select the reference point on the PCB. Now the robot approaches the reference point, gently touches it, recording the height of the previously set reference point, retracts, so we can have a closer overview of the PCB. Now the wizard asks you to take a picture of the PCB. The final heat map will be overlaid on this area you select now. When you click on Next, the robot will move to the calculated corner of the PCB and opens up the settings for the connected spectrum analyzer or vector network analyzer. Here you can select parameters such as the start frequency, stop frequency, bandwidth resolution, whether or not you want a preamplifier, attenuation, and more. Finally, the wizard asks you if you want to measure the X or the Y component, and with what step size between 2 points. With clicking the Start Scan button, the scanning starts, providing you an estimated time until the scan finishes. The figure shows the magnetic near field above the PCB at 233.3 MHz. The red areas mean strong near field. It requires a little experience to make the correct interpretation of the near field map. In this case, the map shows that despite the shielding, the ribbon cable acts like an infinitesimal magnetic dipole. Magnetic dipoles have the characteristic near field patterns shown in the figure. You can also define new probes and choose between already defined ones, and the robot will take their dimensions into account when moving around. Safety features are also included, such as a virtual fence, where the robot can only move inside its defined box. Soon, we will be able to make phase-resolved near-field scan with the help of the VNA. Since we have a 6 degrees of freedom robotic arm, the roadmap includes scanning on 5 surfaces on the reference box enclosing the PCB. This will make it possible to use the measured near field as source for simulations.